Hello folks, we are once again back with our exercise 7.6 and this is the problem number 15. In the last video we did till problem number 14. Now let's see what does this problem number 15 says. It says that we have to find out the integral of x squared plus 1 times log x dx. Now as we always do, we will try to fix these functions and accordingly we will try to use isolate and get the integral. So this is going to be an algebraic function and this is the log function. Since we, according to isolate, log comes first, so therefore u is going to be log x and v is going to be x squared plus 1. Generally we always do du over dx and keep, so that is going to be 1 over x, and integral of v dx is our next step. So that is going to be, we'll take the integral of x squared plus 1 dx. So let's find the integral of x squared. We know it's x cube over 3 and integral of 1 is going to be x. So these are things ready with us. Now let's go for the integral. Integral is u, we know the formula, u integral v dx minus du over dx integral v dx and the overall dx. So that way, for u it is log x, for v it is x cube over 3 plus x, and du over dx it's 1 over x, and this integral of v dx we know it's x cube over 3 plus x dx. We have to take the integral once again, but the advantage here is there is an x common. You could take that out and this x can get cancelled, and that way your work is going to be really simple. So let's see how this works. So the first term, it remains as it is. It is x cube over 3 plus x log x. That stays as it is. Now let's see what happens in the integral. In the integral, as I said, there is at the 1 over 3, I think, no, it's not over. Okay, so let's have the x common. So you will be left with x square plus 1. There is a 3 here, and also there is an x which is there already common, so they can get cancelled. So basically it is to get the integral of this term. So let's see now what will come. It's x cube over 3 plus x log x, and when we get the integral here, maybe we can get the integral right away. So integral of x cube over 3 we know is going to be x square over 3 is x cube over 3, and integral of 1 is going to be x plus c. That's the answer. Now it's only a matter of organizing it. So why have I written it as plus? Yes, it is plus. X cube over 3 plus x log x minus x cube over 9 minus x plus c. So that's going to be our answer. Yeah, that's it. Quite simple after deciding what the whole thing is all about. Okay, that's all for the problem number 15. Before we start the problem number 16, now till problem number 15 we were sticking to isolate and we were doing our questions, but from 15th problem onwards we are going to use a slightly different result, and this result is very important from the MCQ point of view. Generally MCQs they asked on this, they always ask on this concept. So let's get across with this concept and let's see how to apply it in the forthcoming problems. Suppose say if you have an integral which is of the type e raised to x times f of x plus f dash x. Suppose if you happen to encounter such a function, then you actually need not go in for the integral. You get the answer directly as e raised to x fx plus c. That's going to be your integral. So whenever you are able to get a situation like this, that time you don't have to do isolate and all that and like spend your time. You can directly write the integral as e raised to x times f of x. That's going to be your integral value. So it's a powerful result, and proceeding problems they are going to be on that line. So let's see the 16th problem. Let's see what they say. They say that it is, let me turn the page, it's behind. E raised to x times sin x plus cos x. Yeah, it's e raised to x times sin x plus cos x. See, such a beautiful example. If your function was sin x, we all know that derivative of sin x is cos x. So here you have fx here and f dash x here. As I told you, if at all you have a function like this, then we don't have to hunt for the integral. Your answer is going to be e raised to x fx, which is e raised to x sin x plus c. That's it. So these are so if you ever happen to give the if you need to give the explanation, then you can say here maybe f of x is sin x and f dash x is cos x, and therefore we know that whenever you have e raised to x times f of x plus f dash x, the integral is always going to be e raised to x f of x, and that's how you are getting this as an integral. So we could do the next problem, but I think that is a little lengthy. So with the next problem, let's meet in the next video. That's all for this video. We meet in the next video. Thank you.